Welcome to the lecture. You may recall that in the earlier lectures we had discussed the simple linear regression model, and we had found the estimates of the regression coefficients, their standard errors, confidence interval, and we have discussed several other aspects. Now, in this lecture I would like to show you that how these values are obtained in a software. So, in this lecture we are going to discuss about the software implementation. So, just for the sake of illustration, I have considered here a simple linear regression model y is equal to beta 0 plus beta 1 x plus epsilon. So, here we assume that we have got 27 observations, and these observations are collected on the demand of water, and that is going to denote our response variable y, and this is measured in say million liters. And we know that the demand of water depends on the weather temperature. So, we take x as our independent variable, which is denoting the weather temperature on a particular day, and this is measured in degrees centigrades. Okay. Now, our objective is that we want to find out here the value of beta 1 hat, which is given by summation I goes from 1 to 27 xi minus x bar yi minus y bar upon summation I goes from 1 to 27 xi minus x bar whole square, and that we had denoted as say something like sxy over sxx. We also had obtained the estimate of intercept term as y bar minus beta 1 hat x bar. After this, we have obtained the standard errors. Standard error of beta 1 hat, this was obtained as sigma hat square over sxx, and standard error of beta 0 hat, this was obtained as sigma hat square 1 over n plus x bar square over sxx. Okay. So, here you will see that x bar is going to be 1 over 27, I goes from 1 to 27 xi, y bar is 1 over 27, summation I goes from 1 to 27 yi, and n here is obviously 27, and sigma square hat is obtained as sum of square due to residuals divided by n minus 2, that is 25. Okay. So, now there are different types of statistical software which can be used to conduct the statistical analysis. There are some software which are paid software, and some popular softwares are MINITAB, SysStat, SPSS, and there is a long list, but these all are paid softwares. There are some free softwares also, like as one popular software is R. This can be downloaded from the site www.rproject.org, and similarly there is another software, this is Gretel, right, and there are some other softwares also available, and these are essentially the free softwares. So, one can actually use any one of the software whatever is easily available, Here in this lecture, we are going to use the MINITAB. Right, there is no personal bias or personal reason to use MINITAB because it is available to us. So I am going to use this MINITAB. Okay, so now let us come to the software part. And my objective is that first I am going to demonstrate that how I am going to analyze my data, and then I will try to obtain the regression output. One thing which we all have to keep in mind that we have not completed the regression analysis. So when we go for the complete regression analysis, there are some parts in the statistical software outcome which we have not yet studied. So I am going to consider the outcome of a software which we have done. And we are going to demonstrate here that how these quantities which we have studied in the earlier lectures, they are going to be computed by the software and how we can interpret them. So let us come to the software outcome. So this is the window of the MINITAB statistical software. So here you can see that here in the first column, I have already entered the data on the drinking water demand, and in the second column I already have entered the data on the temperature. So you can see here that there are altogether 27 observations. So this drinking water demand is going to be our response variable, and temperature is going to be here the independent variable. So first of all, when we want to conduct a regression analysis, first we have to ensure that the relationship between response variable and independent variable or the explanatory variable is showing a linear trend. So for that thing, this MINITAB have several options. Similarly, other software also have these options, and we go for a scatter plot. And here you can see that there are different types of scatter plots available. So first we are going for a simple scatter diagram, and in this case I am considering the y as my drinking water demand and x variable as my temperature, and I try to plot this graph. So you can see here that there seems to be a sort of linear trend which is here. Right. So I will keep this graph over here, and let us try to explore something more, and later on I will come back to the interpretation of this graphics and software outcome. Now similarly, I try to make here another scatter diagram which is possible in MINITAB, and I try to make a scatter diagram with regression line, because this MINITAB software actually computes the regression line, and it shows the regression line on this scatter diagram itself. So here also we have the same setup, and we try to get this graph. So you can see here with this red line, it is trying to show us a fitted regression line. So this type of elementary analysis gives us a confidence that, well, we can fit here a linear regression model. Right. Okay. So now after this we go for the regression analysis. In MINITAB there is a built-in function for this regression analysis, and we go for regression and fit a regression model. Okay. Now once you come here, you can see that I have given here the response variable as drinking water demand, and this continuous predictor, that is the independent variable or the explanatory variable, this has been given here. Okay. Now you can see here that there are several options here, but at this moment I am not considering any one of them. Right. You can see here we can give the weights, and what I want to show you here, that here I have given the confidence level for all confidence interval as 95. That means my level of significance, that is alpha, is 5%, and the corresponding confidence interval are of 95% confidence coefficient. And we are also going to conduct the test of hypothesis. So you can see there are options for one-sided test of hypothesis and a two-sided test of hypothesis. So we are selecting here the two-sided confidence interval and two-sided test of hypothesis. Here you can see here there are two types of sum of squares. One is adjusted type 3 and sequential type 1. At this moment, I can simply tell you that we are going for a simple sum of squares that we have studied in our lectures, and this is given by adjusted type 3 sum of squares. Okay. Now, you can see here that there are different graphs which can be plotted simultaneously, but at this moment we have not done this part, so I am not doing it. And similarly, the results what we want to have, I am going to consider here only three aspects that I would like to have the outcome from analysis of variance. Still we have not done so, that we are going to do in the case of multiple linear regression model from the next lecture, but still we will need this thing. So I am considering it, and then I want to compute here the coefficients that will give us the regression coefficient estimators, say beta 0 hat and beta 1 hat, and here I would also like to have a regression equation. There are different types of other things like as method, model, summary, fits and diagnostic, Durbin-Watson test. These are the things that we are going to consider later on when we try to do the multiple linear regression model. Okay. So yeah, and if you want, you can store these results, different types of fit, residual, standardized residuals, and leverage Cook's descent, defits, coefficient design matrix. But at this moment, we don't need it. We will do it later on. Okay. So now let me go for this, the outcome of this linear regression analysis. So you can see here, we have got here this outcome, right? So if you use any statistical software, any standard statistical software, they are going to give a similar output. There can be a small difference that well, the analysis of variance can come later on and the regression coefficients can come first and so on. There may be some minor differences in the different types of diagnostics tests that are provided by the software outcome, but more or less this outcome remains almost the same. Right. So what we try to do here, let me try to copy this statistical outcome and these two graphics, and so that we can understand them in more detail. Okay. So I already have copied these things here. So now first let us try to understand this graphic. You can see here on this axis we have here x-axis, and on this axis we have here y-axis. And this sort of this scatter diagram, this is trying to indicate, yes, there can be a sort of linear trend over here, right. And now you can see that this type of line can be fitted, and they are going to indicate the residuals. So now when we try to look at this diagram, this is also the same diagram, but in this case we have fitted this this regression line. So this is giving us a sort of confidence, yes, we can go ahead and we can conduct a simple linear regression analysis of this data. Right. Now I have copied the same outcome that was obtained as an outcome here. So now here is the outcome of the regression analysis that was provided us by the MINITAB software. So first of all, you can see here that the first thing is given by here, this is analysis of variance. But at this moment we have not yet studied the analysis of variance, but I had considered it because I wanted to show you that if you try to look at this column, this line here, error. Here you will see here this is trying to give us two values, one is adjusted sum of square and this is adjusted MS, that is adjusted mean square. So SS means here sum of squares and MS means here mean square. So this is the value which we have to consider. actually this is the value which is our sigma square hat. And sigma square hat, if you remember, we had defined by sum of square due to residual divided by degrees of freedom, that was n minus 2. So, here this SS residual, this is given by this thing. This is our sum of square due to residual. And number of observations here, there are 27 observations. So, sum of square due to residual divided by 25, this gives us this thing. So, in the statistical software, wherever we have mean square due to residual, or sometime in the software this is given as mean square due to error, this gives us the value of sigma square hat, because we had just the 27 observations on xi and yi, and so we do not know the value of sigma square. So, we are going for the option where we estimated the value of sigma square on the basis of given sample of data, and that was estimated as sigma square hat. Okay. The idea of considering this analysis of variance table was simply to show you that how the value of sigma square hat is obtained from the software outcome. Right. Okay. So, now after this we come to this column over here, this coefficient. Right. Now, if you try to see here, we have one thing here which is constant. Constant is nothing but your beta 0. We have considered the model here y is equal to beta 0 plus beta 1 x plus epsilon. So, beta 0 is your constant, and similarly temperature, this variable is here your x variable, and corresponding to which the regression coefficient is beta 1, and this value here, this is the value of beta 1 hat, which was Sxy over Sxx. Okay. And this is the value of beta 0 hat, which was obtained as y bar minus beta 1 hat x bar. Now, we try to consider this column. This is SECOEF. This means SE means standard error, and this column gives standard errors of coefficients. Coefficients are beta 0 and say beta 1, whose estimators are beta 0 hat and beta 1 hat. So, now this quantity is giving us the value of standard error of beta 0 hat, and this, if you remember, we had obtained as sigma square hat 1 over n plus x bar square over Sxx. Right. And similarly, this is the standard error of beta 1 hat, and this we had obtained, if you remember, as sigma square hat over Sxx. Right. Next we come to the third column, which is here t value, and with the t value you can look at this value. This value is corresponding to the test of hypothesis H naught beta 0 equal to 0. We had conducted a test of hypothesis for H naught beta 0 is equal to beta 0 0, which is where beta 0 0 is some known value. So, here we are considering it to be 0. Right. So, this is essentially the value of the t statistics that was obtained as beta hat 0 minus 0 divided by standard error of beta hat 0. And similarly, if you look at this value, this is corresponding to to the null hypothesis H naught beta 1 is equal to 0. You may recall that we had developed a test of hypothesis for H naught beta 1 is equal to beta 1 naught. We are here we are assuming that beta 1 naught is equal to 0. So, this value is coming from this statistics. So, let me write it down here T0 in our symbolic notation, and this will be T1. So, beta 1 hat minus 0 divided by standard error of beta 1 hat. Right. Okay. And now we come to the fourth column, which is here p value. Now, you may recall that while doing the test of hypothesis, we had discussed how to take a decision whether to accept the null hypothesis or not. So, one option was to look on the t tables and find out the critical value, and the second option was to look into the p value. Okay. And if you remember, our rule was that reject H naught if p value is smaller than alpha. Alpha is the level of significance, and that you can recall that in MINITAB software we had given it to be 5%. Okay. So, now in our case alpha is equal to 0.05, and here you can see that this p value is coming out to be very close to 0, and in this case also this p value is coming out to be very close to 0. Beta 0 equal to 0 and H naught beta 1 equal to 0. So, now we can conclude that both H naught and H 1 are rejected. Right. So, based on this, I can conclude that x is the variable which is an important variable, and that is helping us in explaining the variation in y. Right. Now, at the end you will see that we have here a regression equation, and this regression equation has been obtained based on the coefficients which are obtained earlier. And so, drinking water demand, this is here y is equal to, and this is here beta naught hat, and this is here beta 1 hat which we have obtained here times x. Right. So, you can see here this value is coming from here and this value is coming from here. So, based on that, now we have obtained a fitted linear regression model. Right. There are some other options that to compute the confidence interval also. So, they can also be obtained, and based on that we can also find the confidence intervals for beta 0 and beta 1. But at this moment, since we are simply starting, so we are not considering it here, and but looking at the outcome of this software, you can very easily assume that you can find out, or you can identify the values of lower and upper limits of the confidence interval. So, by this small introduction to the software, I have tried to highlight that how to read the software outcome, and based on that we can modify our model. So, from the next lecture we are going to consider the multiple linear regression model, which is more useful in practice. There will be some more issues, but believe me, whatever we have learned in the case of simple linear regression model, that is going to create the foundation for learning the multiple linear regression model. So, we stop here, and till then, goodbye.